Hello my dear students. Today we will learn Pythagoras theorem. Theorem 23 from your book, page 197, Embossed Maths book class 10 or Modern's ABC of Maths class 10. Statement of Pythagoras theorem. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So we draw a right triangle ABC in which angle B is right angle. From right angle, the opposite side we call hypotenuse. So here the hypotenuse is AC. So if we read the statement, in a right triangle, the square of the hypotenuse is AC. It means AC square is equal to the sum of the squares of other two sides. Other two sides are AB and BC. It means sum of the squares of other two sides will be AB square plus BC square. So we can write, given a triangle right angle at B, we can write given a triangle ABC right angled at B. From right angle, the opposite side we call hypotenuse. So hypotenuse is AC. So here square of the hypotenuse, to prove square of the hypotenuse, it means AC square is equal sum of the squares of other two sides. Other two sides are AB and BC. So it will be AB square plus BC square. This is sum of the square of other two sides. Now this picture is not sufficient to prove. So we need the extra part, we call it construction. So we draw the construction like this. From B we draw a perpendicular BD on AC. We name it suppose D. And this is perpendicular. BD is perpendicular on AC, so we can give the symbol of perpendicular. This is the symbol of perpendicular. And here also see at angle B, this is the symbol of perpendicular. Angle B is right angle, and here angle D is right angle. So we write here, we draw BD perpendicular to AC. That is our construction. We draw BD perpendicular to AC. Now by BD we see there are two more small triangles in the picture, ADV and BDC. So now in the picture, in the figure, we can see total three triangles. One is ABC, the original triangle, and other two are the two small triangles ADV and BDC. So in the proof we take this small triangle ADV and we take the original triangle ABC. Between these two triangles we find which angles are equal. So we write proof in triangle, this is ADV and the original triangle is what? Triangle ABC. Between these two triangles, see which angles are equal. In triangle ABC, angle B is right angle. In triangle ADV, this angle D, full name ADV is right angle because BD is perpendicular. So these two angles are equal. So we can write angle ADV from the small triangle is equal from the big triangle ABC, angle ABC, they are equal because each of them is 90 degree. And from the small triangle ADB, if we take angle A, from the big triangle ABC, the same angle A, so we can say angle A is equal angle A, short name will do, angle A, short name, so it will do angle A equal angle A. Why they are equal? Because they are common. They are common, they are actually the same angle. So what we see between the two triangles, two angles of the first triangle are equal to two angles of the second triangle. So these two triangles are similar. Triangle ADV similar to the triangle ABC. Why are they similar? We have to write by a similarity, angle similarity. It means two angles of the first triangle are equal to two angles of the second triangle, so the two triangles are similar. If two triangles are similar, their corresponding sides are proportional. So from the small triangle ADV, angle D, ADV, this is right angle. From here opposite is hypotenuse, what is AB, and in the big triangle hypotenuse is AC. So we can say from small triangle AB and from the big triangle AC, they are the hypotenuse, so they are corresponding sides. And from the small triangle, if we take the side AD, from the big triangle the side AB, they are the corresponding side. So we write here from small triangle AD and from big triangle is what? AB, the corresponding side. They are proportional. So why they are equal? We write in similar triangles, corresponding sides are proportional. Corresponding sides are proportional. So if they are proportional, we have written AB by AC is equal AD by AB. We do the cross multiplication now, or AB into AB is AB square is equal AC into AD, AC into AD. This is number 1 we can give. And similarly we can take the small triangle BDC and the big triangle ABC. The small triangle, which one? BDC. So we write similarly, in the same way we can show that these two triangles are also similar. Triangle BDC similar to the triangle ABC, and if triangle BDC similar to triangle ABC, then also the corresponding sides are proportional. So from small triangle hypotenuse is BC, and from the big triangle hypotenuse is what? This is AC. Hypotenuse is AC is equal, from the small triangle if we take DC, and from the big triangle it is BC, the corresponding sides. So corresponding sides are proportional. Then let us do some adjustment here. So we do the cross multiplication as before. BC into BC is BC square is equal, this side multiply AC into AC multiply by DC, AC into DC. This is number 2. And now we add this number 1 and number 2. So we write here now adding number 1 and number 2. What we get? Number 1 left side AB square, number 2 left side BC square. We add left side with left side. AB square plus BC square is equal, we add right side with right side, AC into AD plus AC into DC, AC into DC. Now we take here common, you see, AC plus AC, AC into AD plus AC into DC. We can take AC and AC common. So if we take AC common, here remain AD plus what? AC is common, remain here DC, AD plus DC. AD plus DC is equal, here is AC into, look at the picture, AD plus DC. AD plus DC is equal AC. So we write for AD plus DC is what? AC. So we can write here in bracket, because AD plus DC is equal AC in the figure. So now we write AC into AC is AC square. AC square. So our proof is nearly end here. See, AB square plus BC square equal AC square. Look what we have to prove. AC square equal AB square plus BC square. This AB square BC square plus BC square is here, and here is AC square. So our proof is finished. We can say here, in a right triangle, square of hypotenuse is equal to sum of the squares of other two sides. So we can write here proved, and it is finished. So thank you, my dear students, for today. Thank you.